In this episode, we turn to a topic that matters enormously in real organizations because many of tomorrow's risks are created while people are still calling the work a project instead of calling it a production system. Project management in the information technology (IT) environment is about guiding change in a way that helps the business reach a goal without creating disorder, waste, or avoidable exposure along the way. For someone studying certified in Risk and Information Systems Control (CRISC), this topic is important because projects are where business ideas become technical reality, and technical reality is where security, resilience, cost, and operational pain finally show up. A brand new learner should think of this subject as the discipline of moving from plan to outcome without losing control of scope, timing, ownership, quality, and risk. When project management is weak, organizations build fragile systems, confuse responsibilities, miss important requirements, and discover too late that the thing they launched does not support the business nearly as well as everyone hoped. When project management is strong, the organization is far more likely to deliver something useful, supportable, and aligned with real business needs. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A project is different from ordinary operations because it is temporary, goal-driven, and focused on producing a defined change, while operations are ongoing and focused on keeping services running day after day. That distinction matters because projects bring special forms of uncertainty. A team may be introducing a new application, migrating data, integrating a vendor platform, replacing old infrastructure, or redesigning a business process, which means they are dealing with movement instead of stability. In the IT environment, that movement can be especially risky because systems are connected, data is valuable, and small decisions can have large ripple effects. A poorly planned project can create outages, security gaps, unusable workflows, unhappy customers, budget waste, and years of technical trouble that the operations team later has to carry. For beginners, the main lesson is that project management is not only about schedules and meetings. It is about controlling uncertainty while important change is taking place. The organization needs a way to make progress without letting the pressure to deliver quickly push it into decisions that feel efficient now but create deeper operational and risk problems later. One of the most important starting points in any IT project is the business case, even if the organization does not always use that exact label in everyday conversation. The business case is the practical reason the project exists, and it should explain what problem is being solved, what value is expected, and why the effort deserves time, money, and leadership attention. If that foundation is weak, the project often drifts because people start solving different problems in different directions. One group may believe the goal is lower cost, another may believe the goal is faster service, and another may assume the real purpose is regulatory compliance or modernization. When those assumptions do not match, the project may still stay busy while becoming less coherent every month. For a beginner, this is a powerful lesson because many project failures begin long before technical work starts. They begin when the organization never defines success clearly enough to guide later decisions. Good project management keeps the business purpose visible so that design choices, budget trade-offs, timelines, and risk decisions remain connected to the reason the work was approved in the first place. Governance and roles matter just as much as the business case because projects touch many different interests at once. The sponsor may be funding or championing the work. The business owner may understand the operational need. The project manager coordinates planning, communication, and execution. Technical teams build and configure the solution. Security and risk professionals help identify exposure and control requirements. Operations teams think about support, resilience, and life after go-live. If those roles are blurry, projects often suffer from silent assumptions, duplicated effort, and decisions that get revisited late because nobody knew who truly owned them. A beginner should understand that strong project governance is not about creating unnecessary hierarchy. It is about making sure people know who makes which decisions, who approves important changes, who resolves conflicts, and who is accountable if key deadlines or risks begin moving in the wrong direction. Good governance helps a project stay calm under pressure because it reduces confusion at the exact moments when confusion becomes most expensive. In an IT environment, where dependencies and impacts can spread quickly, that clarity is one of the main things keeping a difficult project from becoming an uncontrolled one. Scope is another central idea because every project needs clear boundaries around what is being delivered and what is not being delivered. Beginners often assume scope is just a list of features, but it is broader than that. Scope includes the systems affected, the business processes involved, the users being served, the data being moved or changed, the interfaces being built, and the limits of what the project is responsible for solving. When scope is vague, requirements become unstable, timelines slip, testing becomes confusing, and stakeholders grow frustrated because different people are imagining different results. This is especially dangerous in IT projects, where one new request can quietly introduce new integrations, new data handling obligations, new support burden, and new security considerations that were never priced or planned. Good project management does not reject every change automatically, but it does make changes visible and deliberate. For a beginner, the important lesson is that uncontrolled scope growth is not a sign of creativity. It is usually a sign that the project is losing its ability to make disciplined choices, and that loss of control almost always leads to stress, cost, and weakened outcomes. Requirements are closely tied to scope because they explain what the solution actually needs to do and what conditions it must satisfy to be considered acceptable. In an IT project, requirements are not only technical functions. They also include performance expectations, security needs, operational constraints, data handling rules, compliance considerations, user workflow needs, and recovery or support expectations. A project can look well organized and still fail badly if the requirements were shallow, incomplete, or misunderstood. For example, a system may be delivered on time and within budget, but still disappoint the business if it does not support the real approval flow, if it cannot handle expected transaction volume, or if it creates access issues the users never anticipated. For beginners, this is one of the clearest signs that project management is not separate from risk thinking. Weak requirements create hidden risk because teams build confidently toward a target that was never defined well enough. Strong project management invests time in understanding what success must look like from multiple angles so that delivery is not judged only by whether the system turned on, but by whether it actually supports the business safely and usefully. Planning is where the project begins turning intention into a path. Good planning considers schedule, cost, staffing, dependencies, milestones, approval needs, testing windows, communication needs, and the simple fact that other teams are often busy with their own responsibilities at the same time. In IT environments, planning becomes especially important because technology work often depends on things outside one team's direct control. A project may rely on vendor delivery, network readiness, data quality, business user availability, legal review, cloud configuration, security approval, or change windows that are tightly limited by operational demands. If those dependencies are ignored, the schedule may look impressive but have very little chance of surviving contact with reality. For a beginner, the big idea here is that a plan should not be judged by how optimistic it sounds. It should be judged by whether it reflects the real environment strongly enough that people can trust it as a guide. A mature project plan is honest about constraints, clear about sequence, and realistic enough that leadership can understand where pressure points and risks are likely to appear before those pressures become crises. Risk management inside a project is not an extra activity added at the end for appearance. It is part of the project's basic operating discipline. Every meaningful IT project creates uncertainty around timeline, cost, integration, data quality, security, third-party dependence, user adoption, operational support, and the possibility that the chosen design will not behave as expected at scale. Good project management identifies those uncertainties early, assesses their likely impact, assigns ownership, and decides what treatment or monitoring is appropriate. Some risks can be reduced through better testing, better design, or stronger oversight. Some can be limited through phased rollout or contingency planning. Some may need formal acceptance if the business decides the trade-off is worth it. For beginners, This is one of the strongest CRISC connections in the entire topic. A project is not managed well simply because tasks are being completed. It is managed well when leaders understand where uncertainty is building, when decisions about that uncertainty are explicit, and when the team does not pretend everything is fine just because admitting risk would make the project feel less comfortable in the short term. Security and control considerations should be built into project work early rather than treated as inspections that happen after the design is already fixed. When security arrives late, the project may discover that access models are weak, logging is incomplete, recovery needs were ignored, data handling is out of step with policy, or third-party arrangements create obligations nobody priced into the effort. Late discovery usually means rework, delay, conflict, or acceptance of weaker controls than the organization would have chosen if those issues had been visible sooner. In a well-run IT project, security is part of how requirements are defined, how architecture is evaluated, how data flows are understood, and how testing is planned. That does not mean security should dominate every decision or prevent useful progress. It means the project should avoid the expensive mistake of building first and governing later. For a beginner, this is a valuable lesson because it shows that secure delivery is usually easier than secure repair. Projects that include control thinking early tend to produce systems that are easier to operate, easier to audit, and less likely to surprise the business with weaknesses after launch. Another major project principle is planning for the transition from project work into operational life. A project is temporary, but the system or service it creates may remain in use for years, which means someone has to support it, monitor it, update it, respond to incidents, manage access, and recover it during disruption. This handoff often receives less attention than design or implementation, yet it is one of the places where long-term pain begins. A project may celebrate go-live while operations inherits poor documentation, weak training, unclear ownership, missing support procedures, or technology choices that are difficult to maintain. For beginners, this is an important reminder that project success is not the same as deployment. A more mature definition of success asks whether the delivered solution can live responsibly inside the organization after the project team steps away. Good project management, therefore, includes operational readiness, support preparation, documentation, knowledge transfer, and clear understanding of what teams will own the environment once the project closes. In an IT setting, this transition is often the difference between a launch that becomes a stable capability and a launch that becomes an ongoing support burden. Communication is one of the most underestimated project skills, especially in technical environments where teams may assume the work should speak for itself. In practice, projects succeed more often when stakeholders understand what is happening, what has changed, what risks are growing, what decisions are needed, and what support is required from them. Communication is not just status reporting to look organized. It is how the project keeps leaders aligned, surfaces emerging issues early, reduces rumor, and prevents important people from discovering major developments too late to respond well. In an IT project, communication often has to move between very different audiences, including executives, business users, technical teams, vendors, security reviewers, and operations staff. Each group needs a different level of detail, but all of them need enough clarity to do their part responsibly. For beginners, this matters because many projects do not fail from lack of effort. They fail because people were working from different assumptions for too long. Good communication keeps the project socially aligned as well as technically aligned, and that alignment becomes essential when deadlines tighten or trade-offs become unavoidable. Testing and quality assurance sit near the center of project confidence because they are how the organization learns whether the solution behaves as required before full reliance begins. In IT projects, testing should not be limited to the narrow question of whether a feature turns on. It should also ask whether the system works under realistic conditions, whether integrations behave correctly, whether users can follow the workflow sensibly, whether security and access requirements are functioning as intended, and whether failure and recovery scenarios have been considered seriously enough. User participation matters here because a technically correct solution can still fail operationally if it does not match the way the business actually works. For beginners, a useful lesson is that quality is not something added after development. It is built through requirements clarity, review discipline, meaningful testing, and willingness to acknowledge problems before launch rather than after customers or staff are already depending on the system. A project that refuses to learn during testing usually ends up learning in production, where the lessons are more expensive, more public, and harder to manage without damaging trust. Third-party relationships often shape IT projects more than beginners expect. A project may depend on software vendors, cloud providers, consultants, integrators, managed service partners, or external data sources, and each of those relationships introduces coordination needs and risk. The organization may rely on outside timelines, outside expertise, outside support quality, and outside contract terms while still carrying the business consequences if the project underperforms. Good project management therefore pays close attention to vendor obligations, delivery milestones, security expectations, testing responsibilities, data handling rules, and support arrangements after launch. This is especially important when the third party controls a key part of the solution that the business may not be able to adjust quickly if something goes wrong. For beginners, the lesson is that a project is not less risky just because part of the work is outsourced. In some ways, it becomes more complex because ownership and accountability must cross organizational boundaries. A mature project keeps those dependencies visible and governed rather than assuming the vendor will simply take care of everything because a contract exists. Methodology matters, but not in the shallow sense of arguing that one style of project delivery is always superior. Some projects follow more sequential planning and phased delivery. Others work more iteratively, with shorter cycles and more frequent adjustment. In real environments, many organizations blend elements of both depending on the nature of the work. What matters most from a CRISC perspective is not loyalty to a label. It is whether the chosen approach supports clarity, accountability, risk awareness, stakeholder engagement, and enough control that important changes do not slip into production without the organization understanding what they mean. Beginners often get distracted by method names when the deeper issue is discipline. A project can be called modern and still be poorly governed, or it can follow a more traditional structure and still be responsive and intelligent. The mature answer is usually the one that matches the delivery approach to the business need, the system complexity, the regulatory environment, and the organization's capacity to test, approve, communicate, and support what is being built. Method should serve the outcome, not replace thinking about the outcome. Many project failures in the IT environment come from a familiar set of patterns. The business case is weak or forgotten. Requirements are incomplete. Scope grows quietly. Security arrives late. Ownership is fuzzy. Testing is rushed. Data quality problems are discovered after migration begins. Operations is told to support the new system without enough preparation. Communication softens bad news until the schedule is already in trouble. A simple example makes this easier to picture. Imagine a company launching a new customer portal. The project team focuses heavily on appearance and delivery date, but access rules remain unclear, support documentation is thin, the portal depends on an old back-end system few people understand, and users are not involved meaningfully in testing. The launch may still happen on time, but the result can be poor adoption, login issues, unexpected downtime, angry support teams, and a rapid series of emergency changes that cost more than slower planning would have cost in the first place. That example captures the main truth of project management in the IT environment. The project is not really judged by whether it crossed the finish line. It is judged by whether it reached the finish line in a way the business can safely live with afterward. As we close, the most important idea to carry forward is that project management in the IT environment is the discipline of guiding change without surrendering control of purpose, risk, quality, communication, and long-term operability. Projects are where future systems, processes, and dependencies are created, which means they are also where much future exposure is introduced or prevented. CRISC expects you to understand that strong project management is not just administrative organization. It is a form of risk-aware leadership that keeps business goals, technical work, security needs, and operational reality connected from beginning to end. When projects are governed well, scoped clearly, planned honestly, monitored thoughtfully, and transitioned responsibly into operations, the organization gains more than a delivered system. It gains a more stable and trustworthy environment for future business. For a beginner, that is the heart of this topic. Good project management does not simply help the organization finish work. It helps the organization finish work in a way that supports resilience, accountability, and sound risk decisions long after the project itself is over.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.